So this is what $2,000 looks like. This is a water manifold for our spray bars, so the water goes into this manifold and then it gets distributed to the spray bars. We've got our valve, which attaches to the inlet right here. That gets regulated by this regulator, and then it goes into this chamber here where it goes to the spray bars and then out to drain. So this is just a fitting with a very tiny pinhole in it, so it's enough for the water to be able to drain out, so this can depressurize whenever we stop pressurizing it. But it's small enough that it's going to drain very slowly and allow this to remain pressurized. We got a gauge right here to tell us what it's supposed to be at. It's supposed to be at 60. Now you can see right here, you can actually see right through that. So this hole is just drilled all the way through and tapped, so we could just remake this whole thing. The problem that occurs with these is that this regulator goes out. We used to be able to get a rebuild kit for this and just rebuild it. Unfortunately, they don't offer that anymore. So the only thing we can do now is we have to buy the whole thing, which costs over $2,000. This is also a regulator. It's got 1/4 inch MPT threads, so we're just going to attach this to that block and bypass that regulator. So that's all it is. Just one hole that came right from the regulator. So on this side, we got this threaded fitting, and that's got a tiny hole in it that you can see right there. So that's going to allow water to escape. So this is the return, but it's going to escape so slowly that it's going to still allow that chamber to pressurize. Now anything could clog that up, so we have to put one of these filters in, and that's something that has to get replaced every time. And that is going to seal with an O-ring, so that is not a pipe thread. This is a 1/4 MPT tap, so this is for pipe thread. We got a 1/4 MPT nipple, and this is stainless steel, which is very important because the etch will eat anything else. Now we don't have to use pipe dope because this is plastic, but this is one of those things where we want this thing to last and we want to be as sure as we can get, so I'm going to use some. This is Loctite thread sealed with PTFE. So you can see I already threaded that all the way to the threads, and this tap only went in 3/4 of the way. So if I went all the way in, basically I'd just be running this nipple right into the manifold. And the regulator does have a direction, so you can see the water is going to need to go that way. So I need that side to go toward the manifold. Otherwise it will not regulate properly. So then I've got a reducer, so it's 1/4 on this side and then 3/8 on that side, so it's a little bit bigger. I got a 3/8 to 3/8 elbow. And the reason we went with a 3/8 elbow here is because this valve is using a 3/8 fitting on it. So with this, we can just take this off of the existing manifold and run it right into there. The reason I wanted this to be 1/4 is because of the hole size that was already there. So with this, it's just going to make our life a whole lot easier. Now this regulator also came with a couple of caps, so that needs to go on the front and on the back. And when we put the gauge on, we just want to make sure that we're stopping turning with the gauge facing up. So that is it. Now we just got to test it. So I pulled this one off the wall. This one had 2 plugs in the bottom because it didn't need all those lines. You can see the difference between stainless steel and steel. Like it tore that one up. And it about ate all the way through it. So we're just going to use 2 stainless steel. Okay, so we got the one hose coming out, so I capped the other 3 holes, and I took the valve off of here so that we can use that, partially because this hose is different and the fitting is different, but also just because we got a valve there, so we don't really need it. On. There we go. No leaks. There we go.
Yeah, it's coming up pretty fast.
Is it 50 or 60? 60, right?
60.
60.
The regulators are only regulated for a little bit more.
There we go. No leaks. So that one is ready to go. See, this fitting was brass, And it about beat that guy up too. So stainless steel or plastic, and that's it. So it's been a day, still no leaks, pressure holding steady, so I think we are good. And so I did 2 more, so that is how we can turn $6,000 worth of repairs into about $300 worth of repairs. It is worth mentioning that we do now have more parts, which means that there are more points of failure, but the cost savings is worth it, and on top of that, all these parts are easily replaceable. So yeah, I am happy with that.